LGM. We are a company dedicated to improving oil spill response. And the goal here is to improve upon existing booms. So standard booms for, say, recovering oil from an offshore oil spill are very limited. They can travel at maybe 3/4 knot to 1 knot and collect oil. If they travel any faster, the oil simply entrains under the boom and is lost back to the environment. So that's a pretty major limitation. So we're developing a better boom that allows us to travel at, we hope, 2 to 3 knots. That will allow our boom system to collect at least 2 times and maybe 3 times as much oil in the same operational period compared to a conventional U-boom. We had really a breakthrough in our testing. So the prototype 3 seems to be doing what we want it to do. We were able to pull the boom at 2 knots while retaining oil, and it was certainly oil that was skimmable in the boom. So this has been kind of a labor of love for almost, well, over 3 years now, almost 4 years. During COVID in 2020, Michelle Buffanel and I spent a lot of time together going to conference, talking on the phone because we were doing another project together, and we came up with this concept of how to build a better boom. And we sketched out to some designs. We filed a patent application, and then, as I mentioned before, we got funding from Natural Resources Canada to start doing some testing.
We created this deflector that will actually create an eddy within the boom system, which essentially, allows the water and the oil floating on it to lose their energy, therefore reducing their chances to leave the boom system. That can be retrofitted to existing boom systems and with minimum efforts. And it can increase its efficiency by 100%.
This system is amazing because we've taken it over 2 knots. It contains the oil and collects in this pocket and doesn't escape. And I'm looking forward to manufacturing this because I think for offshore and for near shore and even onshore for fast water rivers, there's a potential for this to actually be used.
In the whole concept of spill response, speed is the key. The quicker one can get the oil off the water, then the greater is the reduction of the potential impacts, particularly when you get near to the coastal zone. I believe a really great potential to advance our on-water mechanical capabilities in all environments.
And I'm convinced that this new technology addresses these 2 issues: reducing or eliminating entrainment at higher current velocities and increasing swath width. This technology can be applied to existing boom to double or more their capacity without having to invest in new stockpiles of boom. This will reduce environmental and socioeconomic damages and reduce the overall costs of oil spills.
Everybody knows that oil boom is the weak link when it comes to oil spill response. You have to move at excruciatingly slow pace to be able to keep the oil within the boom. It's a game changer, in my opinion.
A lot of it's focused on offshore collection of oil with higher currents, but I definitely see even more of a probability using it near shore and on rivers for collecting oil in higher currents. More than 1 knot has a lot of great potential to fully support the concept.